This is Geometry 3.6b, talking about angle pair relationships, talking about day number 2. What we're going to work on is identifying what type of angles are represented by the letters in each of the corners. Here we see our two lines and a transversal. Notice that the letters are on opposite sides of the transversal. They're on the exterior, so we call these alternate exterior angles. So we'll come down here under alternate exterior and write in those particular letters. CN and A are alternate exterior angles. Looking at our middle figure here, middle top, we notice that the H and the N are both on the same side of the transversal, both on top of their line. So they're living in corresponding positions. So these are corresponding angles. If these were houses on the corner of a street, they would be living in corresponding houses there. So corresponding would be H and N. These two angles, think about what they might be. These are your choices down here. They are on the same side of the transversal, so they're not alternate interior, they're not alternate exterior. They're both interior. Corresponding is not like that. Corresponding is one interior, one exterior. So these are consecutive interior. Put SA and YT under consecutive interior. Our fourth example, we're looking at DO and LG. They're both inside the two lines. They're on opposite sides or alternating sides of the transversal. So these are alternate interior. The fifth example, the G and the I. Look at where they're located. They're not on opposite sides. They're on the same side. They're not both interior. They're related to each other because they're in the same position at each vertex. To the right and up. To the right and up. They're in corresponding position. So that's GI. Over here, we have the N and TO. The N and the TO are on the same side of the transversal. That's what you have to be observant to. They're both on the same side of the line. They're both below the line. So they're in corresponding positions. So they're corresponding angles. TO and N. So we could come to these four boxes and unscramble the words, unscramble the letters to make words. So let's go with the box that has the least amount of letters in it. That would be this one. What word could we possibly make out of the letters C, N, and A? Would be pretty confident that that's going to be can. Over here, the last one. How could we get a word out of S, A, Y, and T? S, T, A, and Y. Stay. Can stay are the words so far. Here we have four letters. Gold.
I know that one.
Okay, then we have the last one. And there is actually two different sets of words that you can make out of this. What do you come up with? Nothing gold can stay. I believe it's a Robert Frost poem.
Robert Frost?
And you can look into that a little bit. So, okay, we're going to come down here to this figure. One thing we need to make note of, we got this chopped off here a little bit. This should continue and have an arrow at the top, an arrow at the bottom. There is an arrow in the middle indicating that these two lines are parallel to each other. If they're parallel, then we have some relationships between those two sets of angles, or two groups of angles. If this angle here is 125, what is something else we know for sure?
That one is also 125.
Those are going to be 1 and the 125 are vertical angles. Those are going to be the same measurement. 7 would also be 125 because the lines are parallel, so corresponding angles are congruent. We also have exterior angles, which would be congruent. 5 are vertical with the 7, or alternate interior with the 125, or corresponding with angle 1. Lots of different reasons why 5 is 125. What's another one someone sees? 6 is going to be a linear pair. They make 180 with 5 and 6. So that'll be 55. So it's a linear pair with 7. 4 is alternate interior with 6, or a linear pair with 1, or consecutive interior with 5. 2 is vertical with 4, or a linear pair, or corresponding. And then the last one down here, 55. It's vertical with 6, or a linear pair with 7, or alternate interior angles with 2. For all those reasons, it's supported again and again why these are the measurements. So you could come on over here to our values, and you would know that angle 1 is 125, angle 2 we said was 55, 55, 5 was 125, 6 was 55, 7 was 125, and 8 was 55. Notice how we did all our calculations first, then it was real easy to fill in the rest of the questions. If you go one question at a time, sometimes that can get a little tricky. Just go to the picture, decipher what's happening, and then worry about answering the individual questions. Look at the relationship we have with angle 6 and angle 1. Angle 6 and angle 1. They don't have a special name. They're not corresponding. That would be 2 and 6. They're definitely not vertical. That would be 1 and 125. They're not alternate interior. That would be 6 and 4. So 6 and 1 don't have a name, but if the lines are parallel, we know they're going to be supplementary angles. We know they're going to add up to 180 because 6 and 4 are alternate interior, 1 and 4 are supplementary, so 6 and 1 have to be supplementary. We're going to use that as we move down to letter B. We have to continue our picture. We'd have the ends of the lines, and we would have two parallel arrows on there also. So what type of angles would these be? They do seem like an alternate because they're on opposite sides, but they're not alternate interior. They're not alternate exterior. Notice how one angle is small, acute, and the other angle is big. Alternate interior angles would be the same, so this would be x plus 5. So these make a linear pair. These add up to 180. These are supplementary. So we have 3x minus 7 and x plus 5. They add up to 180. So we'll group our like terms together. Be careful when you're saying 3x and x. Some people are making the mistake and subtracting x to both sides and getting 2x as a result. But instead, since these are on the same side of the equal sign, you just group like terms together. 3x's plus 1x gives you 4x's. Negative 7 and a positive 5 gives you a negative 2. Then we add 2 across. That gives us 4x equals 182. 4 goes into 18 4 times when you divide. 4 goes into 18 4 times. Goes into 18 4 times. That would be 16 with 2 left over. So then 4 goes into that 5.5 times. 5.5. So this angle x would have to be 45.5 because 182 divided by 4 is 45.5. What do we know about the relationship here? What type of angles are these? Alternate interior angles. If lines are parallel, that's what we know for sure, right? We can see it right there. The lines are parallel. So if lines are parallel, then alternate interior angles are congruent. If they're congruent, they're going to be equal in measure. So we equal them to each other. We do not add them up to 180. You have to be observant to that. So when you divide by 9, you get 8. On the flip side, we have this puzzle. When we look at some of these problems, it seems more like a puzzle than it does a math problem. Notice that here with this four-sided shape, we have an arrow on either side. That's telling us that these two lines are parallel to each other. So looking at the measurements that they're giving us, what relationship do we know? Do you see any of the type of angles we've been talking about? As soon as you see parallel lines, you should be looking for one of our four type of angles. And you may notice that you have alternate interior angles. You have a zigzag there. So you have 4x that equals 52. So x would have to be 13 when you divide by 4. This is 90 degrees down here. Up here, this is going to be 90 degrees because they are consecutive interior angles. So we know that this is 90. 3y plus 2, and the 4 times x, well, 4 times 13, that's 52. That has to add up to 90 degrees. That's 54. We subtract the 54 across to get 36. Divided by 3 gives us a y value of 12. What do we see from this puzzle? You see a pair of arrows on the lines. What do the arrows mean? Parallel lines. So when you see parallel lines, you're supposed to be thinking about alternate interior angles. So there's your zigzag. So x is 45 degrees. Consecutive interior angles gives you y at 85 degrees. So you're looking for the type of angles. Sometimes it may help you to draw in the parallel lines and draw in your transversal to be able to see these 85 and the y are in corresponding positions. Then to finish up, here are your new theorems that are proving lines are parallel. If corresponding angles are congruent, what's going to happen to the lines? What must be true about the lines? The two lines have to be something. They have to be parallel. If corresponding angles are congruent, then the lines are parallel. If alternate interior angles are congruent, then the lines are parallel. This would be the number 8 down here. If alternate exterior angles are congruent, what do we know about the lines? They are parallel. And this last one, what type of angles are 3 and 5? Consecutive interior angles. If they are supplementary, what do you know about the lines? The angles add up to 180, but what do we know about the lines? Lines can never be congruent. Lines have to be parallel, perpendicular, or neither.